The architecture of the elbow and the wrist will be covered in short duration because of the fact that its implications for us in gross motor action is not going to be as significant as when we were covering the knee and ankle, because of the fact that the hands were freed so that we have fine motor articulation. The fine motor articulation isn't our primary concern right now. We're concerned with the gross motor. So when we discuss the elbow is actually 3 different joints that act in unison and are basically considered one joint. It's a hinge joint that also has rotation. So we have 2 bones involved, the ulnar and the radial. The radial bone actually does not connect in here, but we'll be discussing this joint in a moment. The radial humeral joint and the ulnar humeral joint act in unison to provide this hinging action. This hook that comes in that allows this motion also has a supination and a pronation of our entire forearm. And we hear this frequently, the whole notion of twisting the wrist. The wrist does not twist. This is a function of the elbow. And understanding it's a function of the elbow, there's a connection between the radius and the ulnar, and that interosseous fibrous union that connects these 2 bones together can also be manipulated once we understand the loading implications of those 2 bones acting in concert. So when controlling this joint, either hyperfunction or dysfunction, we must add in consideration of the pronation and supination of the forearm. With the wrist, now we're going to do an actual cursory discussion of this, because in another section of arthrokinetics we will be discussing fine motor application of this function, but not here. This is for gross motor. In understanding the function of the wrist in the arm architecture, we've come to understand that the shoulder functions as a stable platform and providing the freedom of access to the hand. The elbow provides the ability for the hand to extend outward and come inward, as well as modulate the relationship of supination and pronation. The primary function of the wrist, and one could say the exclusive function of the wrist, is to optimize the length-tension relationship of this musculature. We've talked about active insufficiency. As you flex your fist, because of the relationship of these muscles, you can no longer maintain a fist as you hyperflex. The length-tension relationship brings you to active insufficiency. Knowing what the function of the wrist is, we will be able to control the entire shoulder complex through the union of these 3 joints. The range of motion for the wrist is flexion and extension, as well as ulna and radial deviation. These 4 ranges of motion make this a biaxial joint that gives it a 3-degree range of motion. 3 degrees of freedom. In knowing this, we're going to have 6 different functions that we're going to be looking at with the hand, and that is hyperextension, hyperflexion, hyperdeviation, radial, hyperdeviation, ulna, a torsion of flexion and rotation, and a torsion of extension and deviation. So those 6 motions will be what we are working on when we go into understanding the function of locking the entire arm architecture, as well as using hyperfunction to control the joint. In understanding how to manipulate the wrist, we understand the relationship of the wrist-elbow-shoulder complex. In the arm architecture, the wrist's function is to regulate the length-tension relationship of the rest of the musculature. Remember, we said the function of the shoulder is that without the load-bearing qualities of the hip, the shoulder's musculature is to provide a stable platform. So this stabilizing structure can be affected by the wrist, since the wrist function is length-tension relationship. In flexion, we see that side hypotenuse we can control by bringing force up and around, which is going to give a distraction here at the radiocarpal joint. In hyperextension, we're going to have the opposite effect, this distraction here. The deviation is important because as flexion occurs, the deviation will become more and more painful. Because of the length-tension relationship, the muscles cannot compensate for this shearing force. So it begins to hurt more and more as it approaches his body. And his shoulder, it moves immediately downward to relieve the tension. When we see that his shoulder is isolated, when we remove the degrees of freedom on his shoulder, this will start to maximize the amount of force we can apply. Now, in the other direction, flexion and outward rotation and downward, I'll isolate this so he can't go any further. The length-tension relationship is being minimized, so his amount of resistance for which he can compensate diminishes as we combine flexion and rotation, which is actually deviation. So we have flexion, extension, the two hyperdeviations, and the two coupled together. When we move on, our job now is to understand the function of the elbow and how controlling the wrist will lock the elbow. Remember that we have this supination and pronation. Combining that to lock out the elbow, look at him. He wants to contract here. Why? And this is important. Another function of the bicep is tension against this supination. So as he pulls, he's also contracting. We'll understand this when he's on the ground. As he flexes, we can use that to our advantage and rotate outward to cause hyperfunction or dysfunction. Hyperextending the elbow, once we hyperextend the elbow, he's going to lose tension on his wrist. So if we bring out towards the elbow, we can easily take control of the wrist and start to manipulate him the longer the tension of the hyperextension. When we compress, manipulation of the wrist is minimized. So we have to come down and move more towards controlling just the radia and ulna. The wrist isn't going to have as much of a function unless we grab the fingers, lock the fingers, and then start to try and manipulate. But because of the number of articulations from compression on the elbow, this is going to be challenging. Grab a hold and just work with a partner to understand how you can do this manipulation and take these two bones, the ulnar and radial, and lay them across each other. In a moment, we're going to move on to the shoulder and see how this motion, the supination and pronation of the radial and ulna, coupled with the 6 functions of the wrist, act to isolate the shoulder. Okay, now what we're going to see is that there are also nerve plexi in the arm that we're going to work on, both with the, here we are, with the radial and ulna and with the tricep and bicep. First, on the ulna, at the mound of the arm, we can apply force. Now, see, it's really starting to hurt, Mike. And it's not much force yet. If we actually place that into the elbow, we can use this as a fulcrum to hyperflex the elbow joint as well as access that nerve plexi. We're going to see this position quite a bit. We can also take and rotate, bring in. This is going to take the nerve all the way across as well as start to separate the radial ulna and at the femoral radial joint and the femoral ulnar joint. The pain's excruciating. You can add in the wrist and you've diminished the length tension relationship of the muscles, so there's no way for him to resist this. Now, moving on, we see that this same thing is going to be true on the bicep. As you apply force, crushing force across the bicep, this is going to have the same impact as what you've placed on the forearm. However, it's going to be more painful because it's at the root of his body. It has deeper implications because of the soft tissue. Now, a good point of reference here is that you can't apply this kind of nervous pressure and expect the same impact as you move downward, because the central nervous system is going to do a neural shutdown from root irradiating outward. So don't expect to be able to manipulate him here and then come up to the forearm to manipulate him, because it will be stopped here. So if you're going to control the nerves, you have to work upward. Let me turn this way. You can access both of these at the same time if you have proper placement. To twist the wrist will maximize this so that you can access both of them simultaneously. You will be. No, just lay over. Now this is also true on the tricep to apply the pressure. Now it's super painful, and Mike's not getting paid for this, but you can use this or use your head to drive in to move him. Use your forearm. You'll see that driving him with your forearm accesses this nervous plexus in the same way as your shin. But knowing that we only use this to cause movement, it's not for submission. I mean, he might tap out if he's a Sally girl, but but this is not the point. The point is to cause movement. You can't get pain compliance. It's an oxymoron. This is to cause him to move. That moves you into something that's either submission or immobilization. You can consider manipulation of nervous plexi as hyperfunction. However, if I could bring Sean in here, you lay down your back. If you see, Sean has his Uggs on, and if you try and apply nervous pressure onto a person who's wearing Uggs, it's almost impossible. No, okay, probably impossible to apply the same kind of nervous impact on somebody with Uggs. So, it's up to you what you shall do about that. Thanks, Chuck. In a moment, we're going to go on and see how those connect into controlling and manipulating the shoulder. Now, understanding the elbow, we all also have access to, remember, the scapulohumeral rhythm. For sinew separations, as opposed to joint lock, instead of just trying to lock this joint, as we bring the elbow to full extension, this is the elbow's strongest point, because the muscles are actually resistant to tensile strength, and the ligaments are pulling it into full compression. So as we come outward, and remember, here we're on eccentric strength, resist. This is his strongest point as he's slowing down, and it's acting to compress the elbow. So a joint lock at the elbow isn't very functional, isn't very effective to move directly into. You should move around to end up in a locked position. If you move directly there, you're going to have the greatest energy cost, and he's going to be moving into his greatest point of strength. So, understanding this, with the scapulohumeral rhythm, meaning he's got another 8 inches of motion right here, we're going to do, instead of a joint lock, a sinew separation. Let me turn this way. Now, here. Lift up and maximize these 8 inches. Now, pinch at the humerus bone. Don't worry about the lock. Because as you separate, now the joint isn't in a closed packed position. As you put air, well, it's actually fluid, but as you put fluid into the joint, you're minimizing the length tension relationship of the arm. If you add into it the wrist, you can bring it into a closed packed position at the end. Remember, not just the hand, because it can be absorbed here. Grab and control the forearm. If you counter-rotate in two different directions, you can even get some cutaneous, just the old Indian burn trick. But that super hurts as you're turning the wrist in one direction and the elbow, the radial, and ulnar bones in the other direction. But it's the sinew separation that does that. Pull the joint out, then move into a joint lock position. So you have that here. Look how low this is. I'm moving into his strength as I try and pull back here. This is going to give him opportunity to move. And I'm going into eccentric strength of his biceps. And actually his triceps now as he's driving down into my groin. So I pull out and then come back. And it's super painful because instead of a closed packed position of bone, well actually cartilage on cartilage, it's now separated and it starts to bend. So we have hypercompression, or I'm sorry, hyperflexion and hyperextension. Both are a function of sinew separation. Sinew separation here, it's thought of as a joint lock, which is absolutely what it's not. A joint lock, remember, is when the bony ends are fully congruent. This is a function of sinew separation. Do sinew separation to get to joint lock. Don't try and go to joint lock directly. We're going to, in a moment, move on to how to apply this to the shoulder. Beginning with the shoulder, what we're